Welcome to this Stormshield Network Security presentation regarding new routing features in version 2. The presentation will unfold as follows. First, we will discuss router objects with configuration, then use cases, monitoring and debug, and we will conclude this presentation by reviewing some other changes to routing in version 2, such as reverse route or PBR priority. Let's start by recapping the possibilities offered by version 1 in terms of load balancing and failover. So load balancing and failover were available for the default routing policy. As far as policy-based routing is concerned, load balancing was not available. It only allowed for failover, and with the additional restriction that the backup gateway had to be the default routing policy. And regarding static routes, they did not allow failover nor load balancing. In order to answer these limitations, a new object type is introduced in version 2. It is called router object. The load balancing and failover configurations are now stored in the object directly. This allowed for unified configuration for the default routing policy as well as for policy-based routing. These router objects can contain both IPv4 and IPv6 routes. Another thing to note is that router objects cannot be used in groups. So, now that we have seen the goal of router objects, let's see how we can configure one. This is the router object creation form. As you can see, it is a new tab in the network object creation wizard. If you are familiar with version 1, you will see that this looks very similar to the default routing policy in that version. So first we have the list of gateways, so main and backups, then the type of load balancing, the trigger conditions for failover, and last the action to take when failover is triggered. Now let's review all these fields in more details. First we have our gateway list, so main and backup. The gateways in the main list will be the one that will be in use by default, so either one if there is no load balancing, or all of them together for load balancing policies. Backup gateway are disabled by default. They will only be used once failover is triggered. Each one of these lists can contain a maximum of 64 gateways per router object. Now let's see the load balancing policy. The next field allows you to enable load balancing and to choose which type of load balancing will be used. So once you enable load balancing, the traffic will be distributed among all active gateways. This traffic distribution is done based on a hash, so there is absolutely no random here. Depending on the type of load balancing you choose, this hash can be calculated either on only the source IP address or on the source and destination. In this second case, this will also include the source and destination port for TCP connection and UDP pseudo connection. A new feature in terms of load balancing with version 2 is that you can now define a weight for each one of your gateways. So for example, in this example I have two gateways in one router object. Both of them are used in load balancing. The first gateway has a weight of 2, whereas the second one has only a weight of 1. So the connections using this router object will be distributed as follows. 2/3 of them through gateway 1 and only 1/3 through gateway 2. When configuring weight, please remember that it must be between 1 and 1024. Now that we have seen load balancing configuration, let's move on to failover. First, let's see how we will detect that a gateway is unavailable. The first thing you must choose, like in version 1, is the device you will use to test this gateway. By default, we ping the gateway itself, but you can choose another object, like a server on the internet, for example. There are only other settings available only in console for device testing. The first one is frequency, which is how often we call upon hostcheck, which is the script that will perform the availability testing. Wait is the amount of seconds hostcheck will wait for an answer once it pings the device. And tries is the amount of ping hostcheck can lose before considering the gateway unavailable. One important thing to keep in mind is that hostcheck will not be used for router obtained through DHCP or through a dial-up link. As long as the dial-up is negotiated, we limit gateway available. As for DHCP, the behavior is the same. However, it may evolve in future versions as the delays are a bit longer usually than with dial-up links. Now that we can detect when our gateways become unavailable, let's define a trigger that will call upon backup gateways. The condition here will be the number of gateways that we have already lost. So you have several options you can choose from. The first one is to only call upon backup gateways once you have no main gateways active. The second one is to start using backup gateway as soon as you lose one main gateway. And the last option here is to choose a custom threshold, where you type in the number of gateways that you want active at minima. Below this threshold, you will call upon backup gateways. The next option will tell us how many backup gateways can be active at the same time. If this option is disabled, only one backup gateway is used. If it is enabled, all backup gateways will be enabled. The last option in this form will only be used for policy-based routing. It defines the behavior if all the gateways become unavailable. You have two options here. Either you route the traffic through the default routing policy, or you choose to stop routing the packet until at least one gateway is back online. So, as you could see in the previous slides, the possibility offered by default routing configuration in version 1 are all available in the router object configuration now. So the default routing configuration has been changed to only be an object choice now, and you can use a router object to have the same feature as before. Regarding policy-based routing, the configuration has not changed except that you can also use router objects now in your gateway configuration. So you get the same features as for the default routing policy in terms of failover and load balancing. So let's talk now about migration from version 1. The default routing policy you had in version 1 is automatically converted into a router object, which is set as your default gateway. This allows you to get the exact same features as you had. Policy-based routing gateways are also converted to router objects. If you had several filtering rules using the same gateway, only one object will be created and used in all these rules. Now that we know how to configure a router object, let's see a few use cases that were not possible in version 1, but can now be done with version 2 and router objects. First, let's study a failover case. Let's imagine a case where our firewall is connected to 3 internet accesses through gateway A, B, and C. Let's create 2 router objects. The first one, used for default routing policy, will have gateway A as main and gateway B as backup. We also have a second router object, which will use gateway C as its main gateway and gateway B as backup. This configuration will not have been possible in version 1, because if gateway C became unavailable, The backup will automatically be gateway A, and all traffic will go through that gateway, with B still available for backup, but unused. Let's imagine in version 2 that we lose gateway C. What will happen is that its traffic will switch to gateway B, and we still have a separation between our default routing policy and our policy-based routing. This does not prevent gateway A from having a backup. For example, if gateway A also becomes unavailable, all traffic will go through gateway B. Let's see a load balancing case now. In version 1, only the default routing policy could use load balancing. But here with several router objects, it is different. We can have, for example, 2 gateways in a load balancing group for our default policy, and 2 other gateways in another load balancing group for our policy-based routing. We can also mix the previous cases with the first router object with failover, with the first router object using failover for the default routing policy. So this is what we could do in version 1. But we also have another router object which allows for both load balancing and a failover that is not the default gateway for our policy-based routing configuration. The last case I'm going to show you is about the weight in load balancing. Let's take a case where we have 4 gateways. A and B have a weight of 1, C has a weight of 2, D has also a weight of 1, but is a backup gateway, so it will not be used by default. By default, the traffic will be split as you can see on the screen, so 25% for gateway A and B, and 50% for gateway C. 0% for gateway D as it is a backup. So what happens if we lose gateway C, for instance? In this case, we assume that failover is configured to enable gateway D as soon as the main gateway is unavailable. So gateway D takes over, but its weight is only 1, not like gateway C which had a weight of 2. So the traffic repartition is recomputed, and each gateway takes a third of the traffic. Let's see now how we can monitor our routing policy and get more information if it's not performing as we want it to. First, this is an example of a router object in configuration file. Let's quickly review the different fields it contains. First, the section name, default router, is the name of our object. Gateway threshold is the number of gateways that must be active. Below this threshold, a backup gateway is used. Frequency is the time between 2 host check execution. Wait is the time we wait before a ping is considered unanswered. Tries the number of pings we can lose before disabling the gateway. Activate all backup. Do we activate one or all failover backups? The load balancing type. On-fail policy is what we do in the case of a policy-based routing rule with no gateway reachable. And finally, our gateways list, so principal and backup. Here are a few useful commands you may want to use when monitoring router objects. First, gatemon -r, which reloads the default routing policy. Netstat -rn displays the system routes. Reloading the policy-based routing routes is done using enfilter -u, which also reloads the filtering policy. And finally, sfctl-s route displays the ASQ routing table. It is important to note that, as far as the default routing policy is concerned, its gateway will only be displayed if load balancing is enabled. Otherwise, the default gateway will not be displayed in the ASQ routing table. Here is an example of an ASQ routing table. So you can see the different columns here. First, router name, which is the name of our router object, gateway name, gateway IP address, the router ID, which is the system identifier of the gateway, the number of times this gateway has been used, the type of gateway, so is it used in filter policy? LB is for load balancing when used in the default routing policy, the status, so is it used or not, and finally the weight when load balancing is enabled. You can also find the same information in the real-time monitor in a new tab called Routers, where we also can find our two router objects with all their gateway status, addresses, weight. We can also get information through SNMP, but for that you need to download the new version of our MIBs from the URL you can see on the screen. In order to get a better history of how your routing policy behaved, new logs have been added to the system category. As you can see in these examples, they tell you when a gateway starts and stops being used. You can easily identify the gateway. Because you have many information about it here. So its name, IP address, and the router object it is used in. Finally, if you want to get more information about scheduled tasks here, for example, host check executions, you can consult them in the var tmp eventdem.rules file, which will contain, for example, all your host check execution. You can see an example on the screen here, where I have an host check execution planned every 60 seconds. That's it for router objects. Let's now see some other features introduced in version 2 regarding routing. The first one here is policy-based routing priority. In version 1, static routes always had the priority over policy-based routing. In version 2, this behavior can be configured. By default, we will keep the previous behavior in migrated configuration, so that there is no changes or no problem in production. But for new configuration, PBR will have the priority over static routes. This change can only be made in console. It is located in the config files security inspection common file, and the configuration token is PBR override static. 0 is the old behavior, so static routes have the priority, and 1 is the new one, so policy-based routing has priority. In order to take this change into account, you must use the enasq command. The next feature I want to talk to you about is return routes. You may have encountered cases in the past where you wanted to have connections coming from the internet to your firewall, but not through a gateway that was your default gateway. In these cases, you had to create a policy-based routing rule so that return packets would be sent through the same gateway the connection was established. It is important to note that, to avoid any conflict, return routes will have priority over all other types of routing. Let's imagine a case where we have two gateways connected to our firewall. With return routes enabled, when a packet comes in from a gateway, the answers will automatically be sent through the same gateway. This is easier to configure than in version 1, because instead of creating several policy-based routing routes, you only have to configure a list of gateways that can use this feature. So this is done in the routing menu. You have a new tab called Return Routes. Here you can define your gateway list. One thing to keep in mind is that for a gateway to be used as a return route, you need to configure the MAC address in the network object that is this gateway. You can check the loaded return routes in console by using the sfctl-s errvrt command. The last thing I wanted to talk about is just a new administration feature. You can now enable and change the configuration for dynamic routing directly through the web administration interface. There are no changes to dynamic routing features. It is just a little change that has been made to make the administration a little more comfortable. That's it for this presentation regarding routing in Stormshield Network Security version 2. Thank you very much for your attention.